Okay, today guys, we're going to talk about section 10.2, which is arc measure of a circle. Okay, so first of all, when you have a circle, arcs are parts of the circle. So for example, from here to here would be arc AB. And you write that AB with an arc on top. Now you might have other arcs that are bigger. Let's do one in red. So let's say it went from here all the way around to like here, and we'll call that C. That would be arc AC. However, since it's more than half a circle, you have to put another point on here, let's say X, and you'd call that arc AXC. So if it's a little one, okay, so we don't get rid of the AC. If it's a short one, like AB, less than 180, or half a circle, we call that a minor arc. If it's bigger than 180, like arc AXC, you call that a major arc. So minors have 2 letters, majors will have 3. If it's equal to 180, okay, so if the arc is equal to 180, well, that's half a circle, right, because a full circle is 360. So if it's a half a circle, we call that a semicircle. Make it fit. Okay, semicircle, if it's equal to 180. So you have minor arcs and major arcs. Now, how do you know the measure of an arc? Well, start a new page here. When you have a circle, and at the center here, this angle right there is called the central angle. It comes from the radius. So if the central angle, we'll say, was 70 degrees, then arc B is also 70 degrees. Every arc is the same as its central angle. Okay? So I could draw another one over here. Let's go a different color, maybe blue. And let's say if this arc was 70, let's take, whoops, don't want that. That was weird. This arc here, all the way around, would be a major arc. Let's put a letter M over here. Arc AMB goes from here all the way around. Okay. Well, if a full circle is 360 and this one's 70, then that would be 290. So typically we only work with minor arcs, but there are also major arcs. That's why you have to use AMB, because otherwise if you said arc AB, you don't know if you're talking about the blue one or if you're talking about the red one. Now, these are called arc measures, not arc lengths. Later on we're going to talk about arc length, which is another animal altogether. Here's why it's different. The measure has nothing to do with how long it is. It's how far it rotates. So for example, I'm going to draw 2 circles here. A big guy in blue, and let's do a little guy in red. Now let's put an arc in here. Well, let's just make it 90. What the heck? This arc down here would be 90 degrees. But if I had an arc over here, that's also 90. Let's call this one XY. And we'll call this one PM, I guess. Arc XY's measure is 90, but so is arc PM's. But it's obvious they don't have the same length. The red arc over here, PM, is a lot smaller or shorter than the arc XY. Excuse me. But they would have the same exact measure because it's measured from the central angle. Later on, we'll talk about length. That's how long something is from X to Y, or P to M. But the measure is the same. Think of like a merry-go-round or a Ferris wheel. You can rotate the same amount of distance even though it's a different size wheel, but the distance you travel will be much different if you're talking arc length. So you have semicircles, major arcs, minor arcs, and all arcs are measured from their central angle. Okay. Couple things of note is also this. If their two circles are congruent, they'd have the same exact radius. Let's say 4 and 4. All circles are similar, like a big little dude and big dude. Okay, so all circles are similar, but to be congruent, they have to have the same radius. Other thing that's interesting, it's a theorem in the book, but we don't spend a lot of time on it. Let's say we have like a bow tie situation here. Here's the center. We'll go across this way and down this way. And that forms, let's say, arc DM and arc AC. So we got this arc and this arc. Well, what's true about angles 1 and 2 is that they're equal because they are congruent. I mean, vertical because they're vertical angles, which makes them congruent. They're congruent because they're vertical. And therefore, arc DM would be congruent with arc AC. Okay? Because they have the same central angle. So some of the problems you're going to see in the book require a little algebra. Nothing too technical. Let's say you had this, and this arc up here is, 3x. And this big major arc is 6x plus 4. And you have to figure what each arc's going to be. So we'll call this A, B, and we'll put an M over here. Well, we know that 3x plus 6x plus 4 equals 360. 9x plus 4 equals 360. 9x then would be 296. And then x would be 296 divided by 9 rather, which on my calculator gives me 296 divided by 9. Did I make when it comes out nice? No, I didn't. 32.8. Of course, the ones in the book would come out clean. You need to plug that 32.8 back in here to solve for that arc, and plug it back in up here to solve for that arc. So you get many problems like that. Just remember the whole circle has to add up to 360, and that if you have a radius, or diameter rather, that's by default 180. Don't forget that. Okay, that's about all you need to know for section 10.2.